All right, if you're building or investing in AI, we need to talk about one of the most important concepts out there right now, and that's AI memory. So let's just dive right in. You ever have that experience where you're in this amazing, deep conversation with a large language model, and then just 10 minutes later, it has absolutely no idea who you are?
Yeah.
It's this weird paradox of the forgetful genius. We have these incredibly powerful models that are basically born with amnesia every single time you start a new chat. So, what's the solution? Well, the thing that bridges that gap is memory. It is the critical upgrade that turns what's basically a one off, stateless calculator into a persistent, stateful agent that can actually learn, adapt, and remember you. So, here's our game plan. We're going to start with that forgetful genius problem, and then we'll take a tour of what I'm calling the AI memory library to see how it's all organized. After that, we'll check out what the librarian does all day, put a big spotlight on a star technique called RAG, and then finally, we'll open up the playbook for all you founders and investors out there. So first up, why does memory matter so much? Well, to put it simply, an agent's ability to even exist in the world, to adapt to you, and to interact in a way that makes sense over time, it all comes down to its capacity for memory. And this slide just lays it out perfectly. On the left, you've got your standard stateless LLM. Every single interaction is like the first time it's ever let you. There's no history, zero consistency. But on the right, that's a stateful agent. It actually learns from conversations, it maintains coherence, and it adapts specifically to you. That is the power of memory. Okay, so let's step inside our AI memory library. Now, I want you to think of an AI's memory not as just one big database, but more like a library with three totally distinct sections, and each one stores information in a very, very different way. First up, you've got token-level memory. This is basically an external notebook, kind of like a card catalog. It's explicit, it's human-readable text that the AI can go and reference. Super easy to read, write, and check on, but, accessing it can be a little bit slow. Next up is parametric memory. Now, this is the knowledge that's been baked into the model's core programming during its training. So think of this as all the stuff the librarian has completely memorized. It's incredibly fast to access, but it's implicit and it is very, very difficult to change without some really costly retraining. And finally, we have latent memory. This one's the most abstract of the bunch. It's kind of like the AI's short-term working memory. Information that's held in its internal state, often in something called the KV cache, just long enough to figure out what the next word in a sentence should be. It's not human readable at all. You can think of it as the AI's momentary gut feeling that helps it process things on the fly. Now, this is where it gets really crucial, especially for you builders. Look at these trade-offs. Token level is easy to edit and understand, but it's slow. Parametric is fast, but it's rigid and kind of opaque. And latent is just lightning fast, but almost impossible for human to interpret. Choosing the right architecture really means you have to balance these three. So, of those three types, token-level memory, that external notebook we talked about, is definitely the most flexible. So let's zoom in on that, because how you organize that notebook has massive implications for performance. The simplest way to do it is with what's called 1D, or flat memory. And really, this is just a running list of information, like a big, messy pile of sticky notes. It's super easy to add new memories, but as that pile gets bigger and bigger, trying to find the right note becomes really inefficient and, frankly, pretty noisy. So to level up, we have 2D or planar memory. Here, we actually start organizing those notes, connecting them into a graph or a tree structure. This is way better for finding relationships between different pieces of info. But yeah, it costs more to build and maintain this kind of structure. And then you get to the most complex level, 3D or hierarchical memory. This is like a multi-floor library with cross-references between every floor. It allows for some incredibly powerful queries, moving from raw data on the ground floor to these high-level thematic patterns on the top floor. It's unbelievably powerful, but also the most challenging to design correctly. Okay, so we've seen the library's layout. Now let's talk about the librarian's actual job. What are the core processes that manage all this information and keep the whole library useful? Well, it really boils down to this three-step cycle. First, you have formation. That's turning raw experiences into useful, condensed memories. Second, evolution. Integrating, updating, and refining the whole memory library. And third, retrieval. Finding the right piece of information at the exact moment it's needed. And this cycle is just constantly running in the background. Let's look a little closer at that evolution step, because it's a really dynamic balancing act. Consolidation merges new and old memories to create bigger insights. Updating is all about correcting outdated information. And just as importantly, you have forgetting, which deliberately removes irrelevant data to keep the whole system efficient and focused. Now, for any founder or engineer in this space, I guarantee you've heard of RAG, or Retrieval Augmented Generation. It is the absolute star player in that retrieval process we just talked about. And believe me, it is evolving fast. And this quote from the source material really hits on the crucial point here. The whole definition of RAG is expanding. What started out as a simple lookup tool is now evolving into a full-fledged memory system. The line is getting really blurry between just retrieving facts and actually learning and self-improving over time. So look, on the left you have your standard RAG. It gets a question, it looks up an answer in a static database. Pretty simple. But on the right you have agentic RAG. This system is way smarter. It decides if it even needs to look something up, what question it should really be asking the database, and it might even update that database with new info it finds. It's a huge leap from being a passive tool to an active learner.
Okay, let's bring this all together. If you're out there building a company or investing in one, what does all this technical stuff actually mean for you? Where should you be looking for the next big opportunity?
So where is this all going? Well, here are some of the most exciting frontiers. I mean, just imagine generative memory, where AIs create new ideas instead of just recalling old ones, or using memory to build these persistent world models that they can learn from. We're also going to need new tools to actually see inside an AI's memory. And maybe most importantly, using memory as the ultimate weapon to ground these models in fact and finally kill hallucinations. So as you think about your own work, you need to be asking these questions. What's the right trade-off between speed and accuracy for your product's memory? How are you going to handle the cost and complexity as you grow? Do you have unique data that can create a memory-based competitive advantage, a real moat? And the big one, are you just storing information or are you actually building a system that learns? And that leaves us with one final and I think crucial question. We're getting really good at helping AIs remember, but as these systems become more persistent and more autonomous, the equally important challenge is going to be deciding what they should and shouldn't be allowed to forget.